In this first video, I want to show you how we create a Unity project. So the first thing you will see when you have your Unity open is the startup screen with all the project names. We want to go to the New tab and click on New. We're creating a 2D platformer game, so let's call this 2D platformer tutorial, and then select a location where we want to save the files. I want to create a specific folder here that will then store all the Unity files for that particular project. Let's call it 2D platformer, and then we'll go into make sure that the folder is all okay, everything is empty. So there we go, that looks fine so far. And now I want to go back to the Unity screen and then select 2D. If you want to do 3D, you could, but for this one, we're doing 2D. We have the asset packages. There's asset packages you can actually import. Unity comes standard with all these assets already included, so you don't need to download from the Unity store. If there's anything additional that you require, you can go to the Unity store and import those assets into your Unity projects. So again, we want to select 2D for now, and then create the project. We have now set up our first Unity project, and we also have imported the 2D asset pack. If you look at the screen here, you will notice that this layout may be different to yours. You can change it any way you want. I'm going to set it like this and move the project window further down, maybe halfway down this page, and stretch that out. And what you see here is the scene window, and at the bottom you have the game window. I select 2D to make sure we see a 2D view. You could actually change this to 3D if you wanted to, and you can actually build a game in 3D view, a 2D game in 3D view. For this exercise, you'll see we have the camera view here, which is what the camera sees, and the background is blue because of the color set. This is the x-axis. We have the y-axis that goes up and down, and we've got the z-axis that allows the 3D movement as we see in 3D games. But for this exercise, we are using the 2D view, and I'll be using the 2D view for building the 2D platformer game. You will note in the scene view, I can zoom in and zoom out as needed. Now, if I go to the project window at the bottom here, you'll see the assets that we imported are now in the assets folder. And as you get more assets, you will keep them in the assets folder. You can create additional folders to store animations and sprite sheets and things like that. I wanted to show you how we then put a character into the scene view and show you how the camera actually views that actual object. This scene is untitled right now. We haven't saved it yet, and we will work on it and create a scene using a character that's already included in the assets package. So as you can see, this camera view we have here, the blue screen at the bottom is what the camera sees. So that's what the camera is going to view, and this is a preview here as well. So the camera is viewing whatever is in this square that I'm highlighting. So let's take a character. I'm going to go in and find a character that's already created, a robot boy. I'm going to put that in here, and as you can see, I can resize this as I like. If I make mistakes to it, I can simply delete that and drag another version of it into the screen. So within the square, the camera sees it. When it's out of the square, the camera does not see it. I can modify the camera to make it larger or smaller depending on what I want to do. Right now, we want to make it around this size. We have the character here. Now, I want to explain the inspector view a little bit. We'll go through some of these elements here. For now, we want to change the name of the character. Let's call it Robot Boy for simplicity. Let me quickly talk to you about layers. If I click on layers, you'll see that it's set at default. We have these other layers within the project already. I can also go and add a layer, and you'll see that they are pre-built layers. I'll cover the layers in more detail in a future video. But now I just want to create a layer for the actual player. I'll call this layer player, and if I go back to Robot Boy, you'll see that in the hierarchy window, this is basically where you can see all the elements and click on them and make changes as needed. I'll click on Robot Boy, and I want to then set the layer for Robot Boy to be the player layer. So I just drop this down and click on that. We'll cover this in more detail. I need to set this to yes, change children, and I'll show you what that means. When we click on that, if I click on Robot Boy, you will see that there is a ground check and a ceiling check. That means that there is a check done for the bottom of the character. Let me zoom in here. The very bottom of the character will have an option of being detected if it's on the ground or on a surface, for example, that we want the character to detect that there is a surface. This is where we can do a ground check. Similarly, for the ceiling check, if the character hits the ceiling or some level that we want it to stop, then this is where we can make the changes for that. For now, if I want to move this out of that, I can click on that and notice it's moved out, but it's obviously going to affect a lot of the functionality. But in this video, I wanted to show you how we can make some simple changes. Ideally, you want it back in the Robot Boy section so that it then makes the functionality work as it is supposed to. So again, the ground check and ceiling check are now within the Robot Boy actual asset. Let's talk about the transform section. This is where we can change the position, rotation, and scale. Let me reset this for now. So it's all back to zeros and ones. And I can go back to the scene view and notice that the camera and character are within that screen, but not really able to see the character. And that's because of the scale and position of the character in relation to the camera and with the 3D view. So let me change this to maybe -10, and that will move the character, and as you can see, the character is more visible now with the camera. It is quite small, so I can change this to -5, and that would also show the character still visible with the camera. I can then adjust the scale of the character to make that 2, and you'll see that the character changes, but stretched to equalize it, I make it 2. This is not an ideal solution, but that's just an option to show you how the transform works so the camera can actually see the character. Just a quick update on the previous video where we were not able to see Robot Boy because of the camera. The reason for that is if you look at the main camera, the Z-axis for the main camera is set at 0. Robot Boy also has the Z-axis set at 0. If I click on the 3D view, you will see we cannot see the character at all. Now, the reason for that is because it's set at the same Z-axis, all being 0. The way to fix that is to move the camera slightly away from the actual character. So basically, this being the camera, the yellow arrow shows where the camera's recording from. You will see that the character is visible. It doesn't matter how far you move the camera away, the character will be the same size. It's all about perspective. So again, just to fix that, just understand that when you have the camera and the character set at 0 on the Z-axis, you are not going to see the character. The way to remedy that is to probably move the camera to about -5 on the z-axis. That allows you to view the character quite clearly and without having the disappearing character problem. We will discuss more about camera options in the future lessons, but that's just a quick update on the z-axis and the camera view. Now that you're happy with your camera position, etc., if you're not happy, you can obviously move that around as you wish. But for now, we have the camera available, which allows the character to be viewed reasonably well. I want to discuss the ground check and the ceiling check, which we touched on a little bit earlier. The idea is to have a ground and a ceiling so that the character actually detects that there is a platform available and not allow the character to fall through and go straight down off the screen. So let's put in a platform underneath the character, just underneath the character, and let's make sure that the ground check and the ceiling check, in this case the ground check, will then detect through colliders, and colliders we will discuss in future lessons, but let the character know there is a ground available and not let the character fall through to the floor or right off the screen. So if we see how this works, we will hit the play button and let's look at how the character interacts with the actual platform. Now this character has already got inbuilt animations. Notice it hits the ground and doesn't fall through. I'm able to move right, I'm able to move left, and the platform is being detected. If I go jump, notice it jumps quite high, and off the screen we can adjust the movement of the character later on, but it does stop when it hits the ground. Now it falls off the screen because there's no platform to the left hand side of that. So we'll just stop that, and that's just an example of a platform for the ground check. Let's look at the ceiling check. Right now we've seen the character jump and pretty much go off the screen. Let's add another platform here, which will be a ceiling check. Now when we play this, when we jump, it's going to hit the top platform, the top ceiling, and then not let the character go higher than that. When the character moves past the ceiling platform, it allows it to jump right through, but when it hits the ceiling platform, it stops. Now that we've tested the ground check and the ceiling check, I want to talk a little bit about layers in Unity. So we go to the Robot Boy sprite renderer, the sorting layer. Let's drop this arrow down and you will see that we have some layers. Let me add in a few layers here to explain exactly what I mean. So we could call this for now background, and we can call this foreground, and we can call this one player. Basically, it's the way the objects will be rendered in Unity. So how a painting works: first we paint the background, then we paint the clouds, then we can paint additional objects, etc. So let's go back to the actual different layers, and let's maybe move the background first and move the default further down the page. Let's look at what this would be in a typical example. For example, we could paint the background like a sky and make a sky appear first. Then you can have clouds and mountains. So let me label this as sky so we can actually get a visual idea. Clouds and mountains for the second layer. So as the character moves through the scene, it will appear as the sky and the clouds are moving, etc. Then we have the player screen, or the player being rendered, and then we have the default, which is in our example the bottom platform and the top ceiling. And that just gives you an idea how this will be rendered, and the sky appearing first, then the clouds, then the actual player, and then the platform. So if I see the play option now, we can actually look at how this would work, running around, jumping up and down, moving left and right. And we'll continue building on this, and we'll explain more about layers in future videos. The next step is to allocate the objects to the appropriate sorting layers. So in this situation, I click on Robot Boy, I select the sorting layer. We have these layers already built, so I would click on Player here. Just remember there's a section at the top which says Layer. This is different from the section that we're working with now. So in this sense, we have the set at Player. We then have sky drawn first, then the clouds and mountains, then the actual player, and then the default, which would be the platforms, etc. In the previous video, the character was appearing, the head appeared in front of the platform. Now notice that the platform is actually in front of the player's head. So it looks a bit neater. It just depends on the situation that you want to use it the other way. But for this particular example, we want the head not to be visible. We want the head to be behind the platform. So as you can see, this is working a bit better now. And it depends. In the situation where you want the character to go through a platform, you would have the platform drawn first and then the character. Now that we've looked at the ground check and ceiling check, let's look at what happens if we remove these platforms and add in a new platform from scratch. Let's go to the Assets folder. We go to the 2D directory and Sprites. Click on this platform, drag it in. Let me resize this and drag it to make it a bit longer. We're going to leave it at the default layer, which is fine. But let's look at what happens when we play this game now. Watch what happens with the character. The character appears in the game and then falls straight through the platform. Now there's nothing to worry about here. All that's missing is what's called a box collider. So we go to Add Component. I just type in collider, and there are a number of colliders here. We'll discuss this in a future lesson, but now we click on Box Collider 2D, and that's all that needs to be done. Let's play that now, and let's look at what happens with the character now. When the character drops in, notice it stops on the actual platform and then can move on the actual platform. The reason, our character has also got a box collider. So let's go to our Robot Boy character. If I scroll down in the section, you'll notice that it already has a box collider added. So the box colliders prevent the character from falling through the platform. Let's discuss a bit about the box colliders. If we go to the Robot Boy and notice that the circle collider is available as well as a box collider that's located a bit below, we now can go to the character and actually see what that looks like. So as I zoom in, you'll see that there's a box and a circle. The circle collider is the most suited for the legs because the legs are moving. So that would then detect a collision as required. This box is not perfectly suited to this character. If someone's shooting at this character, the actual bullet may deflect or destroy the character even before it hits the body. So we need to make some small adjustments, and you can make adjustments to the box collider as you feel fit. In this case, the head was going through the platform or behind the platform because the box collider is a bit below the head. Let's make some small modifications here by going to the box collider section at the bottom right, and notice that we have an X and Y value. Let's change the size of X to 1 to show you what that looks like. Now this is too large. If bullets are flying towards the character, the bullets will be decimated even before they hit the body of the character. So that's too big. So let's make this to 0.3. Still not ideal because the eye is still visible. Let's change that to 0.4. Again, looks 0.5, a little bit better. But remember, again, the bullets are still going to decimate before they hit the body. So you will need to play around with these values to figure out what's perfect for you. For now, let's go back to change that size to the original 0.28. So let's put that back in. And then you play around with the Y value to make sure that it is a little taller than the head. So when it hits the ceiling, it will stop before the head disappears behind the platform. Play around with the settings to perfect it for your game. So let's look at the rigid body character controller. This will explain how we can add functionality to the actual character. Just move this to the left-hand side and we'll build a simple scene that shows you some of the functionality. In Unity, we have two ways to control the character. One way is by using a custom script where we write a script that explains how the character is going to work. The other way is to use rigid body. In Unity 3D, we have rigid body, and in Unity 2D, it's called rigid body 2D. This is more for beginners because all you got to do is simply tick or fill in a few of the section and you will be able to get the character interacting with the other objects also having rigid body controllers. Now in this script we have a platformer character 2D and a platformer 2D user control. So as you'll see here, we can fill in some of these values, and I'll cover all this in a later lesson, but let's look at the platformer character 2D script. This script will allow us to change the speed of the character, change the jump force, and change a few elements. What you can see here is if I hold my mouse over max speed, I can drag and increase or decrease the speed, or I could manually adjust it by entering in a value here. Because it was about 10, we found that it was moving a bit fast. Let's change that to 5. The jump force, we saw the character jumping quite high. Let's change that to 500. Crouch speed, we don't have anything to do with crouch speed in this particular case. What we want to also look at is the air control. Air control is a neat feature. When you jump, the character can still be controlled. It's a fantastic way because in case you miss the platform you want to land on, you can actually move the character while it's still in the air. So most games will allow you to jump and then move left or right depending on what you want to do, or at least prevent you from just falling down on the first jump. Just give you a better chance of reaching your goal or reaching the platform that you want to get to. Now we've got this what is ground. At the moment it's listed as everything. What we do want to do is to set it at only the platform we created. So on the ground check, you notice that the layer was the default layer. So if we go and check on the platform, you'll notice that it is sorting layer is default. When we go back to Robot Boy, we want to go back to the section where it talks about everything being ground. And let's go to modify that because we only want the platform, the floor that we created, to be the object that it integrates with and then collides with to make sure that the collision is detected with rigid body. So let's go down here and you will see that where it says what is ground, we drop the arrow down. At the moment it says everything. We want to change that to only being the default layer, which would be the platform and maybe the ceiling that we add later on. So let's go here and I need to uncheck all the elements that I have to do this manually and take off all the elements and only leave the default checked. So let's just check the default as well and remove the other two. So we now have only the default layer that it integrates with, and then let's have a look at how this works. So right now the character will appear in the view at the bottom, and we'll be able to interact with the ground. The jump, you can see, is not as high as it used to be, so that's working perfectly. One thing I wanted to bring to your attention is if we click on pause here, and let's say we add some elements into the actual game scene, you will see that these elements all being added, and one thing you do, if you hit play, they all disappear. So be very careful. You want to stop the play of the game before you make any changes to your actual game. So let's look at adding a few things into this scene so we can actually see what the sample obstacle game might look like. What we're going to do is just zoom out and just make sure it works okay. And let's go in and add in some additional platforms. And one thing we can do, because we've already added the rigid body into the platform, if I simply add another platform in here, it will not have all the features or functions of that initial platform. So to do that, we need to copy, and we do that by copying and pasting. So see, if I drag it in here, it doesn't have the rigid body. So what I need to do is Control D, select the element, Control D, and make a couple additional copies of that particular platform with the functions of the original platform. And what we'll be doing here is creating a little bit of an obstacle course. So let me drag one of these to the right here so the character can jump onto this particular platform. Let's move another one maybe to here so the character can actually jump onto this particular platform. Just make it a bit smaller so it's neat. What we also want to do is change one of these platforms to be a wall. So how we do that is we drag this platform here, we change the z-axis to be 90 degrees, and then we move this to the edge of the screen, just outside of the view of the camera. We don't want the camera to see this. I can make it a bit larger and wider, so at least when the character hits the wall, it does not go through the wall. It prevents the user character from moving to the other side. So let's do that on the other side shortly, but let's rename some of these. Let's call this floor. Let's see, let me start from scratch and just work out which one's which. So that's the floor 1. Let's call that floor 1. And we have another one called floor 2. And this will be the wall for now. And this one will be the floor 2. And we've got another one here. Let me just make sure we are okay. Let's drag this. We'll make that as wall 2. So let's do the wall 2 again with the z-axis. Change that to 90 degrees. Move this to just outside the view of the camera. I think I made it in the wrong spot. I need to change the 90 here. Let me drag this to outside of the screen. Again, just a little outside of the camera view. It's not visible, but doesn't allow the character to interact or move past that wall. We'll just add a couple more things, make it a bit neater. So we'll see how the game plays shortly. And let's now add another element in here, which will be a potential bonus pack or something that the user collects in the game. And let me just fix up the names here. So we call this one floor 2 and we call the other one floor 3. So that's where we've got all the floors and the walls. Let's add a power up. So I'll drag one of these pink or reddish boxes into the game. The idea being that if the user picks up these power-ups, it may allow the user character to jump higher, to get to additional levels or higher levels. It may even allow the user to use it for a certain amount of time, where it times out after a certain period of time. So this will be a power-up that we could use. And just imagine a game where the character collects the power-ups, allows the character to jump a bit higher, and then you get another power-up and you keep collecting the power-ups, or it times out after a certain time and the user has to collect even more power-ups to get to additional levels or additional heights. And how it would work is, in the code, we could actually change the feature here which says that if the user picks up the power-up, we can change the jump force to 800 or some higher capacity. So let's play this game now and see how that works. Here's the character. Let's work at how we can jump. Go to the left hand side or right hand side. I can't go to that end. Now I keep going this way. I can jump onto the platform. I can jump again. Oh, I cannot touch the box or power up because we've added the box in. It does not have any rigid body controllers, and you'll also see, because it's set at the default layer, the character is appearing behind the box. Now that we've parented the floors and set some positions, etc., let's look at what the game looks like when we hit the play button. So look at how the character appears. What I want to show you is how the camera does not follow the character. So here we have the character moving to the right, jump, and the camera is not following the character. The character is still moving up here, but the camera has not followed the character. The first thing I'll do is stop this. Let's click on the main camera. What I want to do is rename this main camera to have no spaces. When we'll be using scripting later, if it has a space, the script won't find it. So let's have it with one word, main camera. And now we want to go and have a look at some of the elements of Robot Boy to show you some of the movement settings, and then we'll look at how we add the camera in. So let's go back to Robot Boy and let's look at this script where it actually says we have the 2D platformer character, got the jump force and things like that. This is how the script actually looks. Take my word for it for now. There are no details in this script to explain the left movement and the right movement. That is actually in another script which we already have for Robot Boy, and that is located in the one called Platformer 2D User Control. So let's click on this and you'll see in this script it has jump, it has other awake functions, it's got the get button for jump, input section, etc. Now the input section is here under edit. We'll go to edit, and under edit it has the project settings, and under project settings it's got input. In here you'll see the horizontal, which has the inputs that basically allow for the negative button and the positive button, the left and right keys. So this is where the input controls are detected for the horizontal movement. We have a similar feature for the vertical as well. So right now we have left and right already determined with the horizontal input controls. Now we go to the vertical and the jump as well. We will have similar functions there. So here we have up and down. In this game, we are not using the up and down movement as we are doing a left to right scrolling game. But let's go to the jump setting. I want to show you something else here. We have lots of features underneath here for jump as well. This is for joystick control. We're not using joystick here, so we'll go to the normal section for jump, and you'll see the key used for jump is space. Now, Unity is cap sensitive, so we want to make sure the name has a capital JUMP, but the button needs to be lowercase. So I could call this 5. Let's play the game now and see how that works. So I will show you how when I press the space button, there's no movement, but when I press the 5 key, there we go, the jumping happens. Now I press the space button again and nothing happens, and I press the 5 button again and we can jump. So let's go in and change this to space again. I can't use capital SPAC in here because it will not accept it as an input. The name can be changed with a capital J or a lowercase j. Unity scripting will then be able to detect the name appropriately. But when we put in the input button, we need to make sure that the button is written in lowercase. So you'll see that now when I type in space with a capital S, it won't allow me to enter that in. So the name, again, can have a capital in there or a lowercase JUMP. Just remember, you have to name them properly for the script to pick them up later on. Now let's go in and fix this up and put in the space in lowercase so that the Unity script will work later on with the correct keys. As you'll see just now, when I do enter capital S, PACE, it doesn't allow me. So it has to be lowercase SPACE. So that will fix up the issue with the input control. Now let's look up here where we've got the vertical. If I try and change that to a capital S, notice it will just go blank when I try to change it. There we go. It has to be a lowercase. So let's get on to making sure the camera actually follows the player. The easiest way, but probably the worst way, is to parent the main camera to the character. So I can simply drag this up here, and now the character will be followed by the camera. So wherever the character goes, the camera will follow this character. Now let's look at how that works. You'll see the movement does follow the character, but it's not ideal, and I'll show you another alternative just now. So here we have the character in the game. Let's move the character and you'll see the camera does follow the character. It works okay, but it's not the ideal way, as I'll show you another option now. So let's stop this and let's drag the camera out of the parent relationship with Robot Boy, and let's look at a alternative method of doing that. Let's remove the main camera from the linked to the character for now, and we will look at a 2D follow camera. So we go to the standard assets. So let's click on assets and we go into standard assets. We go into 2D. We find the scripts folder and we have this 2D camera follow. Don't worry too much about this, but what we do is we click on main camera, we drag the script and into the add component section, and that adds the camera into linked with the actual camera. So let's go and click on Robot Boy, add this to the target link. So now the camera is linked to the Robot Boy character. Let's play that and see how that works now. As the character drops in, you will see the camera move a bit better. The camera moves back to the character And now as we move the character, you'll see the camera moves a bit easier, smoother. It moves back and forth and goes a little bit forward when the character moves forward. You can see the camera is moving with the character in a much smoother way. Let's make some additional changes to the camera itself. What we want to do is get the camera to actually start where the character actually is. We don't want the camera to then start somewhere else and then move to the character. We want the camera to start where it is. So let's start at, say, 15 and 5 for Robot Boy. And let's also go to the camera and set it at the same spot, 15 and 5 as well. This way, the camera and the character start at the very same spot. So let's try playing that now, and you will see that the character will fall and the camera will fall a little bit as well, and then it will move smoothly with the character. So the camera is moving quite smoothly with the character. So you can change the speed of the camera, change some of the settings with the camera later on, but for now we have been able to add a camera to the character to enable movement. Now we've got these holes here. We can later on add a background, add the gaps so it looks a bit smoother. We won't add any colliders to the actual spaces, so the character will fall through as intended. I just wanted to add a few more things about the camera. Let's just go to the settings. You will see that you can change some of the settings relating to the camera. Let's go to the actual source of the script, and you see it's public float. The reason it's public is because if you want to create another script later on, you can access these functions even in those scripts. If you set it as private, it won't be available in those additional scripts. So let's look at the damping. The damping is how fast the camera actually moves. We can change that to a lower value, so get the camera to flow a little bit more naturally. I'll make that 0.3. Just the smoothness of the camera. We'll see that when we play the actual game. Looking ahead factor is basically to see how much ahead you can actually view in case of enemies attacking, see how far ahead the enemies are, etc. We don't need this at 2, so let's change that to 1.5 to make it a bit easier. We'll leave the additional settings as is. Let's just run this game and see how it looks. You will see the camera view a bit more smoother in action. So here we are. Here's the character. Let's move left and right and see how that works. I want to make the camera a little bit smaller in a second, but you'll see that the jumping is a bit smoother. It's not moving as far ahead as possible. So let's just stop this. I want to change the camera slightly to make it a bit smoother and closer. Now let's play the game and see how that looks. Again, let's go across and you'll see I can jump. Oh, notice how the character, when it hit the platform, got stuck. So with the box colliders, the character, remember we built the collider around the actual character, and because it wasn't covering the complete character, maybe the head was sticking out slightly, when it hit the actual platform, it basically got stuck on the end. It reacted to this end and got stuck on the end of the platform. So we may need to make some adjustments to the actual platform to make sure that we don't have those types of issues. So as it fell, you'll see here, the head of the eye, because it has ground check on, has basically caused it to get stuck. So you would want to make sure that you adjust the platforms to have a appropriate distance between them to allow that not to happen. So You can do this. There's no hard and fast rule on exactly how to do that. It will require some trial and error. And the way you do that is you actually play the game and test it out. See how the character jumps. So let's go in and move this around. You'll see I can move the platform a little bit this way. And the gap then changes on the other side. You would need trial and error to adjust that. And best way to do it is to play the game. So in test mode, you hit play and just work out whether the character has an appropriate distance or not on the platforms and between the platforms. You'll see here I can jump at this point, move the platform around and test where is the best distance. And as I jump, you'll see whether I either make the jump. Yeah, I made the jump there. It has affected the other platform distance, but let's just go through and look what happens. It falls straight through. As you can see, just might have hit the platform edge, but as you resume this, you'll see that everything is back to normal. Now let's look at how we can add a background. I already have a background imported here. I'll use this for now, and then I'll show you exactly how we import a background and how we can make changes to it. So we go to Game Object, 3D Object, and we click on Quad. Now let's drag this in to where our character is, and I need to make some changes to this quad. The quad works differently to a sprite, so I need to manually make these changes to match up exactly with the camera and where the player is. So as you can see, it matches up okay, and it now is covering the actual screen. Let's add a directional light to make sure it is not too dark. So if you see the 2D sprite, it has the sprite renderer and things like that. This quad, you have to manually set the positions. So everything has been set to 0. I'll just change this to 2, and that will make that change. And now let's hit the play button and see how that plays. So it's 14:6. Now we also want to parent the quad to the main camera so it follows along. Let's see how this works in test mode. Here we go. We can see the background is actually moving with the character. It's not the ideal way. There will be an additional lesson on a scrolling effect with a script later on, but for now this will do. Let's now add in the background as I mentioned earlier. So firstly, let's delete the background and let's start again. Let's delete all this. And now I need to create a folder called extras. I right click, select import new asset, look for the file that you want. I've got a folder here that has all my assets in there. I scroll down to pick the background that I require, select that, double click on that, and it will open up here. We need to change the texture type from Sprite 2D and UI. I need to change that to texture. Once that's changed to texture, you'll see some of the settings have changed. Wrap mode, we need to change that to repeat. So it repeats the background. Now you need to click on apply so those changes are applied. Otherwise you will mix up and not have the appropriate changes. Now the next step is fairly simple. The quad is set to follow the camera. So I just need to go to the background, drag the background which is ready as a texture and drag it over this image, and then the background has been added. So it is a bit stretched out. It's not the perfect fit. You would want to find an image that fits more perfectly. If you now notice that when we test this, the background will stay fairly static, but it does work with the new background. If you're building a game which has a lot of changes like buildings and backgrounds changes, etc., you would want to build a fairly large image that can go right across this page, that continually changes, building heights, roads, etc. This one is 512, but you would want to make something that's more appropriate to fit your scene. That's how you would apply a background. This will work for this particular exercise. Now let's look at the new folder being created. It's got materials and it's created something called star background, which is here. We can make changes to this, and the effects of this particular background, if you'll see here, I can make all the modifications, like change the metallic and smoothness, and quite a few changes here. I'll ignore all these for now because I don't want to play around with this too much, but you can play around and make it best suit your game. Similarly, with the directional light, you can do the same by changing the intensity and the bounce intensity, etc. As you can see, that changes things, but I don't want to mess around with that too much. We just want to play around with the background, show you how I'm able to add a background to this particular game. One quick thing I want to change is the name of the quad. So let's call that background. It's parented to the main camera. I wanted to show you what happens if I parent it to the actual character. If I drag this to the character, it will follow the player quite clearly. But notice how when we play this, the challenge you have is when the player jumps, the blue borders and background is visible. So it's following the character carefully, but the camera doesn't follow the player correctly. So it's something to take into consideration when you're building your game, to make sure it is parented to the main camera. Now that we've added the background in, you'll note that the background does look a bit stretched. And this is because we have the original setting at 512 by 512. So let's have a look at the actual background so you can see what I mean. The original image was 512 by 512. That's a good size for the image. However, because we've stretched it, let's look at the background here, and you'll see that we've stretched it 14 times on the x-axis and 6 times on the y-axis. So obviously not ideal, but for this demo purpose, it is fine. You'd want to make sure that you get the appropriate assets for your game, and we'll change this in the further version of this game, but right now it will do. There are some other options that we can modify later on, but I'll explain that later. For now, let's look at how we can change the lighting of this particular background. So we go to the directional light and we can play around with the intensity. I can lower it, make it a bit darker. Let me just change the setting to 2. The directional light I can also change, but ideally it's not the best solution. You want to play around with the intensity for now. Let's go back to the intensity and let me change that to 2. So rather than play around with it here, let me just change this to 2 so that we see what that looks like. A bit too bright, so let's go to 0.5 and let me play around with the bounce intensity to see what would be ideal. You will find that it's a bit of hit and miss, but we'll change the character and change the background in a future video, so this won't be as relevant. But in case you do find that you need to change the intensity, etc., this is how you would change the background intensity. So as I play, you'll notice that the background is a bit better for now, but let's go in and change some of the textures of the platform. So what we want to do is actually go into the settings for the platform. You'll notice we've got star background here. I'm going to right click in this section under materials and create a new texture. I'll probably import a texture shortly, but if you want to use some of the standard textures, you would probably go about it by doing this. So let's just go in and create that new texture. Right click, create, and for here I'm going to select material, I'm not going to go through all the options under material, but for now, just drop this box down and look at the shader. Call this blue for now. Let me go in here and change this to the option which will be the diffuse shader. I'll use the diffuse shader for now, and let's see how that applies the changes. There we go, that change has been applied. And now we go select, and I'm going to select a color or texture that's better. So let's select that one. And now we see we have the blue texture. So let me select all the floors and drag the blue to apply that to all the floor settings under add component. Notice something has happened. Let me undo that for a second and get the platform in place. And let's go in and do that again. Now I'll drag it again to the actual platform. Let me go to the first one. Notice now the platform has changed color. It looks like it's almost not there. And the reason is the background's too dark, and the blue on the black background is actually causing the platform not to appear. So let's just stop this video now. But if you ever wanted to import a texture, we'll show you that in the next video. For now, when I was playing with the texture here, we had this issue with the darkness. So we had a little issue with the shader in the previous video where the platform wasn't showing very clearly. I want to keep it very simple now and maybe go with an easier version. So let me click on floors, and what we'll do is just change it to a very simple color. So I highlight all the floors. I click on sprite renderer, this section where it says sprite renderer. I could change the material where it says sprite default, but for now I want to keep it simple. I just want to click on color. There's a little color dropper image on the right hand side here, and a pop-up window will appear with all the different colors. I'm aiming for a space style theme, so something with blue. I'll just choose a blue that I feel that's relevant, and you'll notice at the bottom we have these RGB. I can scroll these to pick a more effective color that I want. I do want to go for a blue, but the alpha channel, the A here, will allow me to add some transparency to the platform. Given that we're trying for a space theme, let's see how this looks, and you can actually see the background through the actual platform. Now let's go in, and we've made changes to all the actual platforms. Let's look at how this plays and see how the character interacts between the platforms. So here we go. We jump across. It all works fine. And I want to also add in here the platforms to be at different levels. We'll add some enemy type situations in another video, which will either be something like spikes or an object that the character has to interact with. But for now, let's go into the platform. I'll increase this slightly a little higher to make it a bit more challenging for the character to jump on. So it will require a little bit of testing to get it right. So let's go onto this platform and let's change this to be -6.32 now. But let me change that to something that's a bit challenging for the character. So let's go in here. We got -7.1. So let's change this to -6.1 to see whether the character can actually jump up to about -6.1. And let's see if the character can actually jump to that. There we go, it can jump. And let's change some of the other platforms to some different levels as well. And then, you know, some can be higher, some can be lower. Well, let's change this platform to -5.1. So -6.1, that one was -6.1. And let's make this one to -5.1. That will give the option for the character to jump up a couple levels. The other one, let's move the level down. So let's change this minus 0.1, 8.1, so that the user will drop down to another level. Some little user can interact with that. So let's try and play this very basic platform levels at the moment. So let's see if the user can jump. Yes, it can jump up to that level. Can it jump to the next one? Yes. Now it has to drop down to the additional level down there. And can it jump up again? Yes. So this definitely works. You want to test this out so you can make sure that the character can jump to the different platforms. Otherwise, you're going to have a problem. So let me just see. Oh, notice now the character is actually got stuck to the platform and then fallen off the screen. So we will finish all these changes in the polishing section of getting the game correct. But for now, just remember we had a box collider issue. Let's look at adding some obstacles into our game. Now I'm purposely putting an image into our Unity dashboard that actually is too large. Look at the size, it's 1464 by 2048. Massively large for our game. If I drag this into our game, notice how large it looks as compared to the actual screen. It's absolutely massive. Now, obviously, I'm showing you this just to give you an idea that you may have images that are not suited ideally to the game. We see the scale at x being 1, y equals 1, etc. This is where you start playing around, making sure you make adjustments to make this an obstacle so that the character can actually jump over it. So let's play around with some values. Let's put 0.07 and 0.07 and let's see how that looks. Let's drag this into our screen. Still quite big compared to the character because the character wants to jump over that. 0.05, still too big. Let's go to 0.03, 0.02, and I'll make this the same for the Y. Now that's a more reasonable size. Let's just drag this down to be an obstacle for the player to jump over. You want to play around with the sizes so you get something that's suitable to your game. You want to make sure the character can jump over it from a bit far, not having to jump right from up close to the actual obstacle. So let's play that and see what that looks like compared to the character. And let's see if that can jump over it. Yes, the character can jump over it quite easily. Make it as challenging as you want, but obviously you want to make it reasonably suitable for your game. So let's just play around with the layers. I want to put this behind the platform. So I'll just add a new sorting layer. Let's call this layer items. So we have a layer for all the items that we want. I'll call this one background. Let's call this one extras, player and items. Let me drag these around. So the default to come at the end, we want the player to draw first, then the items to be drawn on the screen. So once we have played around with that, I've called it shock prod placeholder for now. I select that as the items layer. Notice we are using a transparent platform, so the item doesn't show up as clearly as it would if you were using a solid color for your platform. Well, let's make some minor modifications to the layer and let's see if we can make that look any better. But just remember, if you want it to look as clear as possible, clearly defined between the items and the actual platform, you want to use a platform with a solid color. So let's keep moving on. Let's see how this plays. And yes, the platform being transparent is causing the item not to look as clear as possible. But let's move on. What I now want to do is start adding some additional obstacles for our player and then see whether we can jump over the obstacles to make sure that all works. So once you're happy with the actual obstacle, you can move this around and duplicate them. And now we simply drag the object to where you want to put it on. Drag the next one to another level. Put it wherever you like. And this will come with a bit of trial and error to figure out exactly where you want the obstacles to appear. Let's make some modifications and I'll show you how we work on the actual positions to make sure they're consistent. This is a manual task, so you will have to duplicate the obstacles, then move them to where you want manually. And once you have moved them manually, then we can make some adjustments to the actual size and position for the y-axis. So let's click on one obstacle first and let's see where the x and y coordinates are. So we've got it at minus 6.78. I can move this along the x-axis to where I want. The key thing here is to remember the y coordinates. We want to make sure all the obstacles look similar on the actual platform. You don't want one higher or one lower. So I want to make some modifications to the actual obstacles now, taking note of the y coordinate minus 6.78. You go to the next obstacle. I need to go to the next one, sorry. And also make sure it's minus 6.78. Once you're happy with that, you move to the next floor. And let's look at it's minus 6.1 as opposed to minus 7.1. So let's go in and change the y coordinate here to reflect that. So let's make some modifications to those two obstacles at minus 5.68. And then we go to the next floor and make that at minus 4.68. I believe I have made a small error, and let me just double check that. When I go back to the floor, minus 7.1 and minus 6.78, yes, so it's not minus 5.68 and minus 4.68. Let's just change that to minus 4.78. And the other one should be minus 5.78. Just to keep them consistent, these errors might appear in your game. You just want to make sure they're consistent so it looks good for the actual game. Now I can just drag it along and see exactly where I want to position it. Let's play the game and see how the character interacts. Notice we don't have any collision at the moment. We just want to see how the character is able to jump over the platform. If I walk through, it will walk straight through the actual obstacle because there's nothing stopping it from colliding with the character. So let's jump over this and let's see if it works on the next platform. Here we go, and see it walks straight through, but the platform is working, the obstacles are working. If you didn't like the position of the obstacles or you wanted to make it more challenging, you could simply move this along, go to where we are and move this along to make it more competitive or easier. Remember, take note of any changes you make, as if we are in play mode and you stop, you will lose all those changes. So something to remember. We have worked with some backgrounds, we've added some platforms, worked with the character Robot Boy for now. We've added some obstacles. Now let's look at what happens if we want to change the character. The character that we're going to use, given that it's a space theme, will be an astronaut. So to do that, I need to introduce you to sprite sheets. We can go to the assets folder and we'll go into the extras and we'll then import a sprite sheet. And in a later video, I'll show you how we take the sprite sheet and get individual sprites from that. For now, let's go in and import the sprite sheet to show you what we start with. This is not the end result that we're going to end up with, but it's a good start to show you how we go to the extras folder, we right click and click on import new asset. We go to the folder where the sprite sheet is. I'll go into the sample that we're using here, 2D platformer, and I can use the PSD, but for now we're just going to use the PNG graphic file and use that within the Unity program. So double click on that, and that will import the PNG file into our game. Now you'll see that added here with some individual sprites. You can see this little box around them. I can drag this now and show you what it looks like. This is not the actual finished product. Now I'm going to show you how we take the sprite sheet and make individual sprites from that. In this video, I want to introduce you to some basic scripting. So the first thing we want to do is click on our character. We need to firstly change this from Robot Boy to just call it player. So it is the astronaut character. The other thing I want to do is to make sure within player, I'm going to change something called idle to graphics. This will become important later in our script when we reference the graphics. Now let's go back to player. I'm going to scroll down and we're going to find a section here where it says script. Click on this platform character 2D and you will see that this is the actual script. I don't want to go through all the details right now, but you see an option here at the top which says open. Before I do that though, you want to make sure you go to edit and preferences, and here you can click on the external tools. Look at the external script editor. I can drop this arrow down and you'll see it has MonoDevelop, which is Unity's pre-built engine for editing. You can use Visual Studio. For this video, I'm going to use MonoDevelop just to show you how that works. So make sure that's ticked. You can select other editors, but for now, I'm going to use MonoDevelop. Once that's selected, you can go back to the right-hand side inspector window and click open, and you will then be able to open up your project or script within MonoDevelop. So once that opens up, you should see a screen like this. The first section I want to introduce you to is this first part, which is the private float, where we've got things like max speed, the jump force, the crouch speed, air control, and what is ground. Why are these important? If I go back to the inspector window, you will see by declaring these in the script, they then become available and I can make changes in the inspector window under that particular script. So if you go to the player, scroll down here, you'll see we have max speed, jump force, crouch speed, air control, and what is ground. So that's where you can make changes as well. Now let's look at the screen. You may have a different color. You can change that by going into options under tools, and within here you have these different color schemes. You can choose the syntax highlighting, and most likely it'll look white, but you can then change to whatever you feel is best for you to be as productive as possible. Once you're happy with the color, you can simply click OK, and that color will be applied to your script section. Now, let's not play around with the script right now. What I want to do is show you that the MonoDevelop has a debugging tool. So if I click play here, it will then show me there are no errors in the script. It's building and building the assembly. Once that's done, notice there are no errors at the bottom. If I do make a slight modification, let's look at going into the code itself, and let's remove the semicolon here. And when I click the play to debug again, notice that it will throw an error and highlight the next line. after the semicolon. Because we've not ended that line of code, it then does not understand the next line. So you need to put that semicolon back in and make sure that the code then works. So let's look at that again. Put the semicolon back in and click on the play for debugging. And let's see if the error has gone. It's now causing another error here. And that's because I've been playing around with the script. So don't worry about that too much. The script was working. I made some minor adjustments to it to demonstrate an error. That's a quick introduction to MonoDevelop. We'll go on to more scripting in the upcoming videos. We now want to work on player graphics and scripting of that. So we type in private, then we have transform. We give this a name. Let's call it player graphics for now. And we need to end that line with a semicolon. Then we put a double slash and reference to change graphics. So this is just a comment. Will be ignored by the actual code, but just for something for us to remember as we go through with the code. This has come up in red, so I need to go back and type in capital T. Yes, that's a bit better. So what's actually happened is because I've used the lowercase t, we need to put a capital T, RANSFORM, and that will allow this to not show up in red and show up in the default color as we see here. Now let me scroll down to line 32, and here we want to define the function. So let's call this player graphics. This is referencing the player graphics, and now we're creating the new function for that. Let's call that equal, and let's call this transform dot find child, and in brackets I need to put, let's see what we need to put in here, transform dot find child. Let's put some parentheses and some quotes, and in here we put in graphics. And I will add another line in here to then make sure that if any errors are thrown by this particular function, we throw a particular comment on the screen. Rather than the default, we put something custom so we can actually fix up errors. So let's call it if, and we're going to use something for debugging. So we type in if player graphics double equals null, and let's look at the debugging error. So if player graphics equals null, we want to throw a particular comment so that we know there's an error. So to do that, we type in open brackets debug.log error, and what we want to do inside these brackets is to give a phrase or comment to throw on our screen. There is no graphics. Let's call it childed to player. That makes it a bit easier for us to know if there's an error, it will throw a custom message. So we close the line, and that would be the function done. To go back to the top section, we have defined something called private transform player graphics, giving it a specific name. We then have also a comment after the double slashes to basically indicate that if we ever want to come back to the code and not sure what we did at that particular time, this is just a comment. It's ignored by the script. It will not run this particular part because it's got the double slashes. Any of these variables we've defined above have got comments in there. They'll be ignored by the code. The private transform player graphics is the referencing to change the graphics. Now we go down to the line 32 where we talk about player graphics equals to transform find child. This should be in blue, and I'm wondering why it's not in blue as compared to the one above. Let's go back to the actual Unity screen and see. We've called this graphics. Let's go in here and notice we've got a capital G here. That's why it's not finding it. So let's go back and change this to a capital graphics, and notice now the line is now in blue. This additional comment here is to throw an error that's custom to what we need. So that's basically how we've been able to put in a variable, add a function in here. There's one more thing we will add, but because graphics was in lowercase, it was not giving it in blue. Now we have fixed that, and you'll find errors like this that you'll have to modify as you work on your own scripts as well. I'm doing this live, so we will find errors. As I said, I want to add one more thing to the section called private void flip. Within that, we want to change the name of the transform. So let's call that player graphics and .local scale. That's fine. And one more change in the last line. We save this file, and we'll see how this works in the next video. One thing you should always do is debug your code. So as you see, I've pressed the play button here to debug, and you'll notice in line 36, we have a little error which shows up as the Mono developer is telling us that it's expecting a semicolon at the end. So let me save this line of code with the exclamation. Let's debug this again, and notice that this time there are no errors. So let's go back to the main Unity screen. We have saved this already, so we don't need to do that again. Let's go back in and let's play this. And notice now when I move the actual character in the game, the hand is in a fixed spot. When we move left and right, the hand will be in that particular spot without moving left or right. We will do that programmatically later, where we'll be able to move that arm to go left and go right depending on where the character is moving. So it's not going to be fixed in with this character's position. We can change it depending on whether the character is moving left or the character is moving right. When we add weapons, etc., it'll be important to point in the appropriate direction.